Okay, so on here we have a whole bunch of theorems that we'll later use for proofs. Most people find these proofs a lot easier than the ones you did last chapter, so if last chapter is kind of difficult, hopefully these will be easier. So what we're doing for these is we're just reading through them and make sure we understand what they say. So if two lines are cut by a transversal so that the corresponding angles are congruent, then the lines are parallel. So it's just saying, if congruent, then parallel. Makes sense, right? Because we just learned if they're parallel lines, then those angles are congruent, so this is just saying we can do it the other way around. And this is called converse. Do you remember how converse was when we switch things around? So when you see those words converse, it's just saying if we know they're congruent, therefore we can say they're parallel. So the converse is when we switch. And then alternate interior angles converse, so same thing. If we know that they are congruent, then the lines are parallel. Same thing we learned last time, just flipping it around. And then same thing for alternate exterior. Consecutive interior angles are if they are supplementary, then the lines are parallel. And then our favorite transitive one. What does transitive mean? It means we can like move it, transfer from one to another. And so this is just saying if two lines are parallel to the same line, then they are parallel to each other. And this is a statement you guys saw a lot of last quiz. So if P is parallel to Q and Q is parallel to R, then we can transfer this whole side and this whole side to make P parallel to R. Questions on those? No, last class's notes. But you will have a quiz over these proofs next class. Yes. Alright, flip on over. So, linear pair. What do you guys remember what linear pair means? Yeah, so linear pair means they add up to 180. And so it's saying if we add up to 180 with congruent angles, what does each angle have to measure? 90, right? So if they're congruent angles, then each one, the lines are perpendicular. Do you guys remember a perpendicular symbol?
Yes.
If not, that's our perpendicular symbol. So that's linear pair perpendicular. Perpendicular transversal theorem is, so again, transversals when we're transferring, we have three things we're transferring. So it's just saying if it's perpendicular to one of two parallel lines, it also has to be perpendicular to the second because those angles are congruent. So if we're dealing with parallel lines, then the angles are congruent, which means they're both perpendicular. And then this is just doing it the other way around, saying if we know that these two angles are perpendicular, then those lines have to be parallel. And congruent supplement. So just if two angles are supplementary to the same angle, or to congruent angles, then they are congruent. Is that one common sense, or is that confusing? It's all right. So if they're the supplements to there, they have to be the same angle. And same thing with complements. So congruent complements. If they're complementary to the same angle, then they have to be congruent. Okay, so when we start working, I'll give you guys just a list of what all these mean so you can do it on here. It also has a couple things we used last chapter, but mostly it's just the definitions here, so you can come back to these pages to see what they mean. And we'll be using these for the quiz next time also. So flip on to your next page. Yep. We do proofs almost every unit until Christmas. And then we don't really do them in the spring.
Oh my gosh!
Yeah, so they change a little bit. Like this time the proofs are about these, and a lot of people find them easier. Later we'll do proofs about like congruent triangles. So it changes, but proofs is just a big part. So every new thing we learn, there's usually a lesson of proofs in it also. Okay, here we go. We are given that angle 2 is congruent to angle 8. We're asked to prove that R is parallel to S. Before we start the proof, can you look here? If 2 is congruent to 8, how do you know, before you prove it, how do we know these lines are parallel?
They're alternate exterior. That's why.
Mm-hmm. And so, yeah. So we could just do a one-step proof and say alternate exterior converse. But they've given us statements, they want us to go a little bit roundabout way. So how do I know that angle 4 is congruent to angle 2?
Because of the little congruent sign. And they're vertical.
Vertical angles, yep. So all we have to do is recognize those are vertical angles.
Yeah.
And it's technically vertical angle congruence theorem. But if, I don't care if you do, like, simplify things here, you just know on a quiz or test, that's what the whole thing would be called. How do I know that angle 4 and angle 8 are congruent? Corresponding. Mm-hmm.
Corresponding. Yeah.
Okay, and then how do I know that angle R is parallel to angle S? I mean, sorry, line R is parallel to line S. No, I have to prove it from what's already here. So getting from here to parallel, which proof do I use for that? Corresponding converse, right? So converse is when I'm going from the angle to the parallel. And so I just proved that those are corresponding angles, and so then because they're corresponding angles, they're congruent, I know the lines are parallel. So you put that word converse in when you're going from the angles to the parallel line. All right, second one. What's my reason for the first? Given. What do I do when I have a symbol like that in my given? I define it. So someone just told me that's, so that's my definition. Okay, so just remember, those of you who struggled with proofs last time, if I have a symbol like this or a word like complementary, supplementary, I'm going to define it. All right, what's number 3? So that's given, and then, like you said, number 4 is where we just define that word, right? So complementary means they add up to 90. All right, how about number 5?
Oh, transitive.
Transitive, okay. So the rest of you who haven't been saying anything, are you following, or am I going too fast? BJ's not the only smart one. But he is very intelligent, yes. Okay. So the next one, we have what we're always looking for here. Those of you who this is still hard, is saying, okay, where did the angle 3, measure of angle 3 plus measure of angle 6 at the 34? And it showed up here. Where did measure of 3 and measure of 4 show up? It showed up here. Since they both equal 90, that means it's transitive. All right, someone beside BJ, because I already know he knows the answer, and besides Kyle and Chase. What do you think happened to go from 5 and 6? What did you say? Subtraction, right? So we just subtracted out the 6 from both, the 3 from both sides. And so that was just subtraction. All right, so someone who hasn't volunteered an answer yet. What happened for number 7? What did you say? Yeah, all that happened is we went from equals, measure of the angles equal, to the angles are congruent. So that's the definition of congruent. All right. Someone who hasn't said anything yet. What do you think for number 8?
Oh, that's other one.
No, you said something. You can't say it.
No.
Okay, transitive. But has 5 showed up so far?
Or
Substitution or symmetry, I'm hearing. So, tell me this. Where's angle 5 coming from? The picture, right? Because we can't take it from the proof. That's our last step. So it's taking it from the picture, saying angle 5 is congruent to angle 4. How do we know that? They're vertical. So if you have something that shows up and it hasn't been in any statement yet, and it's not a given, then it's going to come from the picture. Vertical. And then what's 9? No, proves never a reason.
No, I know. I'm just saying.
Prove it. How can we prove that angle 5 is congruent to angle 6? Because it's what?
No, because it's alternate interior. What?
Okay, but that's true. They're alternate interior if they'd given us the definition that these two lines are parallel. But since they didn't, we have to see where did 5 and 6 show up before here. So transitive, right? So that's the transitive. Easy or hard?
Easy.
It's a lot, isn't it? Yeah, that's a pretty long one. Okay, ready for the next one?
Let's do the last one.
Okay. First of all, there's a typo here, and there's supposed to be a third given. We just made a mistake. So can you guys write in C is parallel to D? Okay, so someone who hasn't said anything yet. This is an easy one for you to talk. What's the first one? What do you say? Given. All right. What's the second one? So the definition of perpendicular if they'd given us a perpendicular. But so now the perpendicular sign showed up, and that means we have to, if it's we're just putting it in there. And so it's saying A is perpendicular to C. So basically it's telling us that angle 1 and angle 2 are both right angles. So we have to come back here. Which of these 3 ones with perpendicular in the name? Yeah. Linear pair perpendicular, because we know the 2 angles equal each other, so therefore that line, they have to both be 90 degrees, right? So that's one of the new ones there. Is because they're a linear pair, it means it's perpendicular. Just like last class we talked about, if a plus sign shows up in there and it's never been there before, you're going to use one of the reasons with addition. If a perpendicular sign shows up and it's never been there before, you're going to use one of the perpendicular theorems. Okay, someone who hasn't said anything, number 3.
Honor.
What did you say? Given. I think you told me last time, but I'll accept it too. Okay, so if C is parallel to D, how do I know that A is perpendicular to D? So again, it's going to be one of those new perpendicular ones. Can you figure out which are the new perpendicular ones?
Transverse. It's transversal.
Alright, I heard like 2 people find it. Did anyone else find it?
It's transversal.
Yeah, so, alright, let's go back to one talker. And so this one's going to be if we know that they're parallel, then the second angle also has to be perpendicular. And so here they just told us that the lines are parallel, and so therefore A also has to be perpendicular to D. So that's the perpendicular transversal. Good question. We could abbreviate them, but in notes I like to write them out just in case someone doesn't understand my abbreviation. Okay, B is perpendicular to D. What's my reason? Given. All right, and the last reason?
Wait,
yeah, it's the converse, but the converse is, did I do, yeah, so this one, we don't actually have the word converse in there, but this last one is basically like the converse. So lines perpendicular to a transversal. So if they're both perpendicular, then they have to be parallel. So, yeah. All right, you guys ready for the next page or not yet?
Yes.
All right, this next page is some actual problems. So that was our page of proofs. Now these are called crook problems.
We try it. It says we try it. You try it.
Okay, you try it.
All right, let's go. Don't know.
Do you want me to do a demonstration first?
Yeah.
Okay, because you try is down here.
Oh.
Okay, so what we do here when we have crook problems is we draw a parallel line. Okay, so that's step one, is we draw a parallel line right here in the middle. And we know if we mark it parallel, then we can use the angle pairs we know. So if I have a parallel line through here, if this is 54, what would this be? 54, right? And if this is 48, what would this be? 48. And so to find angle 1, what do I do with 54 and 48? Add them together. So 54 plus 48 equals 102. Yeah, sometimes we'll end up with like a supplementary angle pair or something, but pretty much that's it. So here,
Draw your line.
I draw my line. So if this is 111, what's this side of angle 3? Is it 111?
100.
So are these okay, so tell me, now I have this. Are these angles congruent or supplementary?
No, they're supplementary.
So that's where you just have to notice depending which angle they give you, because now they gave me the consecutive interior angles. And so if this is 111, what's this one?
Oh, 69.
69?
Okay.
So we do 180 minus 111 to get 69. How about this one?
80.
80. And so what's 80 plus 69? Is 149. So then I still add them together to find angle 3. It's still those two together. So these ones are really easy as long as you just remember, draw that parallel line and then and it's all from there. Okay, now's the you try. So go ahead and try it. Okay, so you guys just did this one. When you drew your parallel line, what two angles did you get in the middle? 59 and 131? 49, right? So how do we know that this one had to be 49 and that had to be the same? Yeah. So we always look, alternate sides mean they're the same. So if the angle they gave you is alternate side of what you're looking for, it's the same. If it's the same side, you subtract. So 180 minus 131 to get 49. And then we just add them together. What was your answer?
108.
All right, how many of you started working on the next example? How many of you finished it? Yay, one person. Okay. So when we start working on it, what should we do first? Label. So angle 1, x plus 3y. Angle 2, 2x plus 30. Angle 3, 5y plus 20. And then I have two variables, so I'm going to have to set up a system of equations, right? I'm going to have to set up two equations and solve them. What would one equation be?
X plus 3y equals 2x plus 30.
No.
I mean, no, equals 5y plus 20.
Yeah, so I can do my corresponding angles equal each other. And so x plus 3y equals 5y plus 20. And what would my other one be?
X plus 3y plus 2x plus 30 equals 180.
So these equal 180. Or I could take my consecutive interior angles and make these equal 180. So there's actually three possibilities there. Okay, and then I'm going to solve. What do you think the easiest way to solve this type of equation would be? Okay, so let's start by simplifying the second equation. So I'll combine my x's to get 3x plus 3y, and then I'm going to subtract 30 so that it's over with 180. So it equals 150. So I just simplify that equation first. How would I simplify my second equation?
Subtract 3 from
Yeah.
both sides.
So I want to get my y's on the same side, and which side I move them to probably depends on whether I want to solve a substitution or elimination. How many of you like substitution better?
Oh.
How many of you like elimination better? How many of you have no idea what I'm talking about? Okay. That's what I thought. Okay, do you want me to demonstrate both substitution and elimination? Or do you want me to do the one I want to do?
Do the easier one.
Substitution.
It's not easier, it's just preference. Okay, we'll do substitution. So if I'm doing substitution, I'm first going to go ahead and simplify this so that I now have x equals 2y plus 20. Okay, so if I'm doing substitution, what I have to do is solve one of my equations so that a variable is by itself. And then I just take this and plug it into the place of x. So my equation becomes 3 parentheses 2y plus 20 plus 3y equals 150. And then I solve from there. So that gives me 6y plus 60 plus 3y equals 150. 9y plus 60 equals 150. Yeah, if you're coming from regular Algebra 1, you guys, I know, didn't do much systems. They didn't cover systems in pre-AP Algebra 1? No, they did back in the 8th grade? A little bit? It was pretty brief, because it's not big on the EOC test, and so they don't spend a lot of time on it, but it's something you have to know.
That was like half the fun.
Yeah, that was half our test was this.
Oh, really?
Yeah.
Okay, so once I have y, what do I do?
Plug it in.
Yeah, so I just come plug it in. And so x equals 2 times the 10 I solved plus 20.
Where you 2 from?
So I'm just plugging in 2's here. I replaced y with the 10 that I just solved. And then plus 20. And so what does x equal? Okay, and then if I want to check, I can come back and check 40 plus 3 times 10, so this would be 70. This would be 50 plus 20, also 70.
Oh, never mind. You found y. So you got your.
So I found y, I found x.
All right, I got it.
Do you guys want me to show you
No.
No? Elimination? No? Okay.
More tests.
Okay, I'll show elimination later, but let's move on. Let me stop the recording.
You work with